right? Now, this is the type of analysis that I've done, right? I want to do, basically. So I haven't run my circuit yet, right? So there are many ways now to run the circuit. You can either go to actions, right? Then you go simulate. It runs the circuit, right? That's one. Or you can use these shortcuts that have been displayed here. So there's a guide that's running here, and as you can see, it writes run simulation. So if I just click here, my simulation runs, right? Then you just say okay. You don't do anything else. You just say okay, right? Now, if you want to see, right? If you want to see the status of your simulation, right? If you want to see the state of your simulation, right? Do not close this. Just move it. Just drag it, right? Just minimize. Right, you want to see, it says analysis complete, means my analysis was complete. It says, it's basically saying, okay, my circuit was fine, right? But I want to see whether this is true. So I have to click here where it says, can you read that? I can just minimize this so you can just see one thing here. It says refresh op values, refresh op values. So what this probe does, or what this menu does, is that it shows me the voltage drops in my circuit if they were correct. So I'll just click on it. Then if you can see, it's saying node 1, I don't know if that's clear. It's saying node 1, it has 12 volts, and node 2, it has 4.8 volts. And is this correct? If you do calculation wise, this is correct. This is the voltage drop across that 6K resistor, right? So it means my circuit is correct. Now I want to check, are the voltages coming in, are the currents passing through, is that correct? Is everything correct? What I'll do is I'll choose a probe to, this end, which is 1, 2, 3, 4, the fifth sort of component, it's a probe to. So I'll just click on that probe. Then this display button shows, right? So this parameter and value. What this does is, if you click, like what we always say, you measure voltage across a component and you measure current through a component. So if you want to see current through resistor 1, you just click on the resistor. If you click on the resistor, it will show you current, blah, blah, blah. My current and the power through that, my current is 1.2. Don't worry about this capital M, right? It's actually milli, 1.2 milli, right? Since we are saying this is just a one single loop circuit, the current in this whole circuit should be the same. Let's check. Okay, device is R1, which is resistor 1. Let's check our R2 if you are going to see exactly the same current. No, it is the same. Look, R2 and my current is 1.2. Yep, my current is 1.2, exactly the same as R1, right? R2, my current is 1.2, which is correct. Then if I click on the voltage, I should see exactly the same current, right? Now, if you click on the node, you find the voltage at that node, V1, node 1, V, voltage at node 1. So if I want voltage at node 2, I just click on node 2, voltage at node 2 is 4.8. So this is the summary, right? When you're just doing a simple operating point analysis, right? You can find whatever you want, and yeah, we can work on that, right? So I'll just remove that. Okay, that was the first section, right? Now let's make this more interesting, because in this one we didn't really find many interesting stuff. So you can click this edit text, right? So what edit text does, okay, let me just show you. So there's next to the running guide, there's an edit text sort of tab. If you click on that edit text tab, what it does, it gives you the summary in case maybe you are running a very big sort of circuit and you just want a summary, right, of what's been happening in this circuit. You just click edit text, so it gives you a summary, so you can actually name the circuit, like, okay, if I remember Samu, then what was happening at the resistor 1, what was the value of the resistor 1, what was the voltage of that resistor, then, showing all the circuit summary, if I may say, right? Now, that was it. Simple circuit, 2 resistors, and that's it. Now, let's do something interesting. Okay, let's do something interesting. Let's add an active circuit component. So what I'm going to say, I'm saying let's remove, okay, let's close this, right? Let's remove. Now we are restarting again. So I want us to remove this resistor, right? Remove this resistor and try and put, what do you call it? Try and put a diode there and see what happens, right? Remove the resistor and try and put a diode there and see what happens, right? So not this. Let's leave this one as it is. Let's remove this resistor. So you just double click on it, it highlights, then just press OK for now, then delete, right? It removes the resistor, right? I want us to put a diode, right? But this diode, I want us to use a diode that's already been defined or used in this circuit. But in case you make this mistake, so you go to parts, then a diode is an active circuit, then you just press diode, right? This one, as you can see, is written unknown, right? Why? Because this, if you want to build your own diode, right? Like what is a diode is just a semiconductor, so you can actually model your own diode with different saturation currents. So you need to have a model number, part number, then important parameters here. When you go to model parameters, right? You need these saturation currents like IS, you need this. Then you see the difference, right? If you use different saturation currents, right? So in case you use this diode and you want to use this diode, just writing a number, just writing a model number or part number does not work, right? You need to add all the parameters of that particular diode. The characteristics, normally they're shown on the data sheet of that particular diode that you want to model, right? So in this case, in this experiment, I don't want us to use this one. I want us to go through the long way and they have a predefined diode already that we can actually find in the lab, right? So this diode we want to use is it's a 1N4148 diode. So you go to parts, X browser. Then on X browser, right, we will just scroll till we get to it's written diode, right? So I click on diodes. Then, as you can see, there are many diodes. There are bridge diode, the junction of few defect transistor regulator diodes, there are photodiodes, right? Photodiodes, yeah, mostly used in these car sort of lights. There's Shockley diode, there's the Zener diodes. We just want a switching diode, yeah, just a small switch. It works like a switch if you want. Just this, right? Then exactly what you want, 1N4148 diode, right? Then if you find it, right, you can add it to the parameter list if you want to use it later, but then that does not place it on this, right? You have to hit place, right? Then it places the diode, 1N4148 diode. If you want to see now what I was talking about, look, if we double click on this diode, it has all the parameters already. That's a part number, does not mean that's enough, right? You need to add the model number, the type, then look. You need to add all these values, and one of the most important values is this saturation current, IS, of the diode, right? So we're not touching anything, we're not changing anything, we're just placing this diode here, right? We connect the diode between node 1 and node 2. We just put it there, right? You can leave it as diode 1 if you want, that's not a problem, right? Then on this diode analysis, we want to change the analysis, okay? Initially, we did what we call, an operating point analysis. Now, I want us to do a DC sweep on this diode, right? So remove operating point analysis. I want us to do a DC sweep. Now, once I click this, we're gonna see a drop-down menu. So this drop-down menu is very important, right? So if I see this, right, I can use auto sweep in this case. So it asks me the source that I want to sweep, of which the only source that I have in this case is this 12-volt source, which is written V1. That's the name of the source, V1, not 12 volts, but V1, right? So that's the source. Then I go to start. What start means, it means at what value do I want to start my sweeping on? What value do I want to start at 0 volt, or I want my diode to start, or my sweep to start at 2 volts? So the start, so here I'll just fill in as we go. So I'll say V1, that's my source. Then start, I'll start this simulation at 0 volts. So if I just said 0, it understands 0 volts. Then I want to end my simulation. Where do I want to end? This can run up to 12 volts, right? I can end wherever I want. Let's say I just want to end at 5 volts in this case, right? As long as it's within this 12 volts, right? It's fine, right? So I can go from 0 to 12 volts if I want, right? I cannot go from minus, in other words, right? Then steps, right? Now this, as I say, DC sweep is not time step, it's a voltage step. So I want to do this sweep from 0 to 5 volts in what steps? So in this case, I just say in 0.01 volts steps, right? You don't need to write the V, right? If you write the V, look. If you write a V like this and you say, okay, it refuses. Please enter valid numeric, right? It means that V is not supposed to be there, right? So if by mistake you do this, then it will refuse. So remove that V, then you just say, okay, right? Now that you say, okay, right? You just make sure that leave that DC sweep only selected, right? Then you click done, right? It understands now we're going to do DC sweep, right? Now, let's continue. We have to run it, okay? We can either go the long way, action, simulate, or we can just run right here, right? So you run it, right? It finished running. So, but now I haven't displayed anything. I can just say, okay, it does not change anything. So I'll just minimize this. Look. This is my output. It's just telling me analysis complete, right? Yeah, but it does not show me my 0 to 5 volts was my analysis. Then my DC voltage was my input. Then Y1 was my test point, right? It just means it was measuring voltage at the output here, right? It's measuring voltage at the output, which is at node number 2, right? But this does not give me more details. Let's say I really want to see more details. I don't find any more details. So what I'll do is I'll go to actions, right? To see more details, I can actually choose what I want to see, my input voltage versus my output voltage, because you're saying when you connect a diode, a single diode like this, right? What you're actually doing, right? You're doing a sweep. You want to see how the diode operates. In other words, you want to say, is it true that we say a diode does not operate before the forward bias voltage? You're saying a diode operates between 0, in this case, around 0.4 volts upwards, then it switches on. Before that, it will be off. Is that true? We want to see it, right? So we go to scope. Then on scope, you choose. So the voltage that you want is voltage at node number 2. So you choose your V2, right? You just choose your V2, then you say add. Okay? I'll just remove that. Look. I have it now. I can just maximize this. Look, this is my output voltage, right? I said, let me run from 0 up to 5 volts, right? Then this is 500 millivolts, which is 0.5 volts, right? Just before that, maybe around 400 millivolts at this point, right? My diode switched on from 0, because this is 100, this is 200, this is 300. From 0 to 350, it was the output of the diode was 0, right? It was not conducting. The diode only started conducting at around 350, 380 volts, the millivolts. Then it conducted, then it switched on. Then from there, of course, it becomes linear, right? Then it will go to saturation depending on how much voltage you can withstand, right? But what we're interested in seeing is was this true, right? Right? We saw that, okay, this is true. The diode won't operate before its forward bias. It will only switch on at around, in this case, this particular diode switched on at around 380 millivolts, right? So that was a DC sweep, just a simple DC sweep that we did, right? Nothing much. We don't want to, you can save this, yeah, if you want, but no, we're not doing that, right? You can switch on, right? That was one type of analysis that you can do with a diode, right? Now, I want us to do one simple analysis, which is interesting, actually, more interesting. Now, we are saying, well, that wasn't the function, right? We just saw how the diode can operate, right? It switches on at 0.38 in this case. But that does not give us more information about, or we haven't explored, the functions of the diode. So the diode is actually used for rectification purposes, right? If you have done power electronic converters, or just before power electronic converters, you have seen a bridge rectifier or half-wave rectifier. If you connect one diode the way you connect it, and we assume that our resistor, which is R24K in this case, is the load, and we give an AC signal, right? We can do a rectification. A rectification, we're just saying it's changing from AC to DC, right? AC signal to DC signal, right? If you use one diode, you will have what we call a half-wave rectifier, right? I'll do another lecture actually on this, rectification on half-wave and full-wave rectifier. So stay tuned. I'll do this sort of lecture to show what really happens if you use 4 diodes, right? We call this a bridge rectifier. What really happens, how can you actually have a half-wave and full-wave rectification. So in this way, having one diode, what we just have to change is the input voltage. We make it an AC signal. Then we want to see if we can have this half-wave output voltage, rectified half-wave output voltage. So stay tuned. So what do we have to do? We have to change one thing. We have to make it a transient analysis, right? Then from there, we have to actually input an AC signal, right? So I'm going to start with inputting an AC signal. So on this circuit, I'll just double click on my voltage source, since it's an AC voltage source that I want, right? So on voltage source, double click on the voltage source, right? Then I will see this dialog box that has been shown here. I'll go on to trans generators, right? Because that's the generator that I want to use, right? I'll tell you why am I saying a trans generator, right? Because you use transient analysis in this case. You're saying you want to see what happens, the operation of a diode from 0 volts, right, till it reaches steady state. So I'll do a transient analysis in this case, right? So on that, I'll choose trans generator. So where it's written none here, right? Just double click, enter, right? So it gives me this. So I can enter as much as I want. As you can see, I can enter a pulse. If I want to enter a square wave, I'll use this pulse. Then it has got the rise and fall time. But if it's a square wave, then my rise and fall time will be 0, right? If you need any more explanations of that, just write to me. Then I'll explain better. But then a rise and a fall time will make you create this particular type of signal. But if you say this rise is 0, this fall is 0, then you are going to create exactly like a square wave, right? But you can create as much signals as you want. So we can create a piecewise linear, okay, PWL, right? PWL, because as you can see, we are just given these sort of 1, 2, 3, 4, 5, 6, and 8 boxes. So PWL is whereby you actually define this signal using the text box, right? Using the text, you define this signal using Notepad, right? Define a signal using Notepad, then actually call it, like you're calling function in the programming, right? You're calling this Notepad into this as an input. That's where you use PWL, which is piecewise linear, or exponential if you want to do an exponential. So in this case, I just want us to input a simple sinusoidal signal, an AC signal. So if you click sinusoidal signal, you can see there's offset, there's peak amplitude, right? Amplitude, you know, that's this exactly, it's explained already. Amplitude, you're saying, is from the 0 line to the maximum. So you can define peak amplitude, or you can define peak to peak amplitude, which is twice the amplitude. Or you can define